What's up, everybody? It's Mrdothemath here, and today we're going to talk about solving linear inequalities, right? So before we go into solving linear inequalities, let's look at a few things, right? So these are our inequality signs. You got the greater if, this is what it is if the variables on the left side of the inequality. You have your greater than, your less than, your greater than or equal to, less than or equal to, right? And so when you're actually graphing these on a number line, the endpoints are significant. When it's greater than or less than, the endpoint is open. It's an open endpoint, which means that that number is not included, right? Greater than that number, not that number. Less than that number, not that number. The same with greater than or equal to, less than or equal to. That's shaded because it represents the or equal to part of it being greater than or less than, okay? So that's something that, to think about. Now, with solving, when solving inequalities is the same as solving equations, right? The only thing is when you divide or multiply by a negative, the sign flips, right? The sign flips. So basically what happens is, if I have -2 is greater than, say 10, right? When I divide by this -2, what happens is the sign changes directions, okay? That's what this says, right? When you divide or multiply by a negative, the sign flips, okay? Now let's look at some graphing, something that we was talking about here. So if I was to graph like x is greater than or equal to -3, right? What that means is the or equal to is going to be a solid line, a solid circle, right? A solid endpoint. Greater than is going to be going towards positive infinity. And so let me backtrack. When we talk about greater than and less than, we're talking about the solution as the number approaches either positive infinity or negative infinity. And so in this case, the x value can be -3 and all the numbers bigger than -3. So when I graph this, this would be -3 and going towards positive infinity, right? If it was x is, let's look at this example. This is one that's big. 5 is greater than x, right? 5 is greater than x. This is not quite the same, right? And so what I would advise you to do is to flip it, right? So move the x to the left side. Now when you move the x to the left side, the sign has to flip as well. So whereas this says it's greater than, notice how the arrow's pointing to the x, right? The x is less than. So 5 is greater than x, which means x is less than 5. So flip it this way and then graph it. Less than, open circle, right? Less than approaching negative infinity. So it would look something like that, okay? And that's how you pretty much graph it, okay? Let's get to the meat and potatoes, all right? So let's look at a solving problem. So we're gonna solve 2x plus 1 is less than or equal to 6x minus 1. Again, you solve the same way as if this was an equal sign. So the first thing we want to do is we want to move a number, right? So why don't we, because we want to keep the x on this side, we're just going to subtract both sides by -6, right? Subtract 6 from both sides, I'm sorry. This cancels, you're going to have 2x minus 6 is going to give you -4x. Remember, different sign, subtract, keep the sign of the bigger number, then you'll be exact, all right? Is less than or equal to -1. Then we're going to subtract 1 on both sides, right? So now we end up with -4x is less than or equal to -2, right? Dividing by -4, dividing by -4. Dividing by a negative, the sign flips, right? So where it was less than or equal to, it's greater than or equal to 1/2, right? Because you divided by 2 negatives, you get a positive solution. Now let's graph it. Right? So x is greater than or equal to, so it's going to be a solid number here. It's going to be solid. And then you're going to be going towards positive infinity at 1/2, okay? Right, so that's that. All right, I'm trying to make sure I had a breakup. Cool. All right, so that's solving. Let's look at some compound inequalities. So when you got compound inequalities, you got two situations. You got and compound inequalities, and then you got or compound inequalities. All right, and statement. And compound inequalities basically means that the graphs are included. Or they run into each other, right? That's what and means. So at this example, you got -6 is less than x, which is less than or equal to 2, right? With compound inequalities, the other thing that's going to happen is the arrows are going to be pointing in the same direction. They'll always be running into the same direction, which essentially means that they're going to run into each other because one situation x is going to be greater than, and the other situation x is going to be less than, right? So if you were to graph this, one thing you could do is rewrite it into two inequalities. So again, if you put the x in front for the -6, it's open, right? So it's x is greater than -6, right? When you bring that over, you flip that sign, all right? So we got x is greater than -6, and then we have this one, x is less than or equal to 2. All right, let's graph it. Open, open. All right, greater than -6. So let's graph the first one. X is greater than -6. So that -6, always start with the smallest number. So you got -6, greater than, open circle, and going this way, right? And then you got x is less than -2, less than 2. 2's bigger, so we're gonna come over here. Less than or equal to, closed circle, right? And less than, so we're going that way, right? So essentially they don't run into each other like that, right? So you move the arrow and then draw the lines. So that's 2. This is a compound, this is an and compound inequality. Let's look at an or inequality. So for or inequalities, they are running away from each other in opposite directions, right? So you'll have x is, for this example, x is less than or equal to 1, and x is greater than 5. Not and, it's or. Okay? You'll graph it on the same number line. Start with the lower, smaller number. Less than or equal to, closed circle. Less than equal to, going towards negative infinity, 1. And then you have open circle, 5, right? Open circle 5, x is greater than, going to positive infinity, right? This is what an or would look like. And run into each other or run away from each other, okay? Let's solve one now. Let's solve. Good. Where's my eraser? Ha, it's always been here. All right. All right, so let's solve this one. -4 less than or equal to 4x plus 8 is less than or equal to 8. Okay, when you have an equation like this, what you really have is two equations, so break those up. So you got this equation, -4 is less than or equal to 4x plus 8, and you have this equation, 4x plus 8 is less than or equal to 8. Now mathematically you couldn't do them together, right? You couldn't do them together, and you'll also get different numbers. But with the compound inequality, like we showed you earlier, there's two graphs. When you have an equation, it's two equations. So let's make our two equations like we did. Now solve. Move this 8 over. Subtract 8 from both sides. So you're gonna have -12 less than or equal to 4x, right? Then divide. Pop out. Divide by 4, because that's connected to the x. X is going to give you -3. So when you rewrite it, it'd be x is greater than, flip the sign, greater than or equal to -3. That's the first one. The second one, this one we're going to subtract 8 from both sides, right? So you get 4x is less than or equal to 0. When you divide by 4, x is still going to be less than or equal to 0. So this one's going to be x less than or equal to 0. If you look at both of these, the arrows are already running into each other, right? And that's what an and inequality looks like, right? So let's do it. So we have closed circle. No, yeah, we're gonna start this -3. Closed circle, -3, greater than. Then we got at 0, closed circle, 0. So this is what it looks like. Okay? Cool. And let's look at an OR inequality, and then I'll leave you alone. All right. So with an OR inequality, they're just going to give you two different inequalities, and you're going to solve the same way you would a regular solution. So you're going to have 7. Let's have 7 minus 9. 7 minus x, is greater than 9. Or 6 is less than or equal to 8x minus 6. Okay? Do the math. You got a regular number over here, constant over here. So you're going to move this 7 over. Subtract 7 from both sides. Minus 7. So your negative x is greater than 2. You already see what's going on. Since the variable is negative, that means we're going to end up having to divide by negative. So we're going to divide both sides by the negative 1. When you divide, you're going to get x is less than, now, negative 2, right? When you divide by negative, you flip the signs. We flipped it, right? Flip. Let's do this one. 6 over here, we'll move this 6 over. My 6 plus 6, right? So it's going to be 12 is less than or equal to 8x. Divide by 8. Then that, you won't divide all the way out, so you just reduce these or simplify them. You'll get 3 over 2 less than or equal to 8. X. I'm sorry. 3 over 2 less than or equal to x. Right? Let's rewrite it, putting the x in the front. So it'll be x is greater than or equal to 3 over 2, or 1.5, right? So here we go, let's graph it. Start with the smaller number, negative 2. Is less than, open circle, going towards negative infinity, negative 2. The bigger number, 1/2, 1.5, right? So it'll be greater than or equal to, closed circle, going to positive infinity. All right? So essentially that's it in a nutshell, right? That's what we have for solving linear inequalities. And then once you go a little deeper, we're solving compound inequalities, where we have the AND inequality, compound inequality, and the OR compound inequality, right? So if you have any more questions about this, feel free to send me a message, and I'll do my best to help you out. If you haven't already, don't forget to like and subscribe. Until next time, this is Do the Math out.